Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep and Yes, and welcome to this BARC and HAL atomic series. Yes guys, so as you know, we have started with the BARC and HAL revision sessions, practice sessions dedicated for your preparation of BARC, HAL and the other examinations to come up in your way, right? And yes, per subject we have giving around 2 to 3 classes based on the depth of the subject in that examination, so that you practice enough questions of that subject. And for the 2 days, that is today and tomorrow, I am going to take up the digital electronics, important questions, important areas to be discussed. Let us see what are those questions. Yes, let's see, everybody ready, everybody enthusiastic. I see people joining very slowly. Yes, let the rhythm set up very quickly. Yes, come on everybody, do share the session among your friends very quickly so that we can begin up this session. Right guys, okay, good evening all, keep joining the session. So as you know, the examination for BARC and HAL is going to start from 7th of April, right? Both of them going to start around 7th of April. So I hope you're revising up your notes. A few days back we also talked about the strategy of BARC and HAL, and when I was taking up a small session talking about the strategy and study plan, what should be a routine, so students were like very much interested to bring upon some practice sessions for BARC. Okay, but right now, yeah, when I start, students are joining very slowly, but yeah, let's wait that students can join quickly. Yes, so guys, so let's begin up the session. You know, the exam is on 7th April, so now you can say 1 month, just little more than 1 month, and BARC is an examination where even the body, the conducting body, examination body also will suggest you to apply through gate and without gate, because the cutoffs are not known right now. The cutoffs will be only known after the online examination. So BARC is a very important examination, and also HAL. What are the number of vacancies? What is the pattern? Everything we have different separately session conducted for BARC, separately session also conducted for the HAL. Very good evening all. So chalo guys, begin karte hain session ko. Yes, so the major topics that I am going to cover in this class, today's class of digital electronics, is logic gate and combinational circuits. Of course, we'll try to incorporate 2 or 3 more types of questions, but these are the major topics that is highlighted in front of you. This is a brief intro about me. If anyway in some case new to my session, this is Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from the Indian Institute of Science, Bangalore. And yes, having spent more than 11 years in this industry, trained more than 50,000 students, and my major area of expertise in technical will include control, digital, signals, EMFT, and in the general area I'll deal with the maths and the aptitude. Very good evening. Yes, keep joining. Students are now joining slowly, and I also request you to share up to all of your students, all of your friends, especially those who are preparing for the BARC or HAL examination. Okay guys, so gate 22 is over, and let me keep you updated that some of you might be looking, yeah, maybe your juniors might be looking for a full-fledged dedicated preparation of gate 23 or maybe gate 24, right? So what is the right way of beginning that preparation? What should be the first steps that you should take? How much time you should dedicate, and what BYJU'S Exam Prep GATE YouTube channel is going to offer for gate 23, gate 24, everything means me and Ashutosh Saxena sir are going to speak in this session. That is on 5th March 8 p.m. We'll talk about the strategy. We'll talk about what is the correct timing for gate 23 or 24 to start, and what can be the tips and tricks from the BYJU'S experts so that you get the best results in your upcoming gate examination. So please mark the date. This is going to come live on the 5th of March 8 p.m. Yes, 5th of March. That is this Saturday. That is the Saturday 8 p.m. just this Saturday, 3 days ahead at 8 p.m. we are going to come live. And also guys, okay, this is regarding to the upcoming GATE examination, but other than that, right? If you are not very much satisfied with your gate performance, you might have almost got an idea, little bit idea about your gate ranks or score. And if you are expecting low gate score, but still you have any dream in your mind that yes, I need old IITs or IISc, I want to go to IIT Bombay or Kharagpur or Delhi or IISc, the known institutes. Okay, is it still possible with low gate score? Yes, somehow it is possible up to a certain extent, and that is yes, some interdisciplinary branches or some branches which students usually don't opt. But yeah, I'll talk about those branches or those interdisciplinary branches, what is the placement scope, whether you should opt or whether you should not opt. So how to get into the premium institutes with the low gate score, what branches you can opt, or maybe you can think about the MS courses and etc. All this we are going to take up in this session, and this session is live tomorrow. This is going to be live tomorrow. Okay, ये हम लोग कल लेने वाले हैं tomorrow, that is the Thursday at 10 p.m. This goes live Thursday at 10 p.m. Okay, right? Okay. Yeah, regarding to all foreign universities, Akhidesh, there will be the separate sessions also coming up. Okay, regarding different aspects, separate sessions will be coming up. What all you can get from GATE. Okay guys, chalo. So guys, now let's get started with the question. The first question, what is the output Y? What is going to be the output Y for this logic circuit shown below? Come on guys, yes, let's get started. Now finally we start with the questions. Have a look into the question and just see what should be the correct answer for the question. What should be the correct answer for the question, everybody? Okay, what is the output Y? 0, 1, or A XOR B XOR C XOR D, or none? Okay, so yes, anybody, if you are solving it up, you can also comment up your answers. Check kar lete guys. So first of all, you have 2 input XORs, and finally you have a 4 input XOR gate. Have a look into this detailed circuit. So guys, what is the output of this XOR gate? This is A XOR B bar, and by the properties A XOR B bar, if any one of the variable is complemented, then the XOR gate can be taken as the XNOR gate. So then it is A XOR B. Okay, so Surajit says 0. Okay, Pantham also says zeros. Come on, everybody keep solving the question. Okay, now the output of the second gate is directly A XOR B, right? That means यहाँ पे XNOR और यहाँ पे XOR. So these two, what I am getting on the first 2 lines is the different case, complement cases. Okay, complement cases. Okay, let's say if I call this as, ध्यान देना, let's say if I call this as X, so this becomes X bar. XOR and XNOR are complement of each other. So what do you get here is X bar and X. Okay, let's look at the bottom side of the story. This is again C bar XOR D, and if any one of the variable is complemented, so it can be written as the XNOR gate, C XOR D, right? Then C bar XNOR D bar, XOR D bar, both the variables are complemented, so that is basically XOR only. Okay, that is basically XOR. Okay, so now let's say the C XOR D. Now let us say that this C XOR D is Y, so C XNOR D will be Y bar. So here you get Y and Y bar. So basically these 2 lines are complement of each other. These 2 lines are complement of each other. So how many ones you are going to get? How many ones you are going to get? You are going to get total 2 ones and 2 zeros. Okay, because X and X bar only one will be high, other one will be low. Y and Y bar only one will be high. So 2 ones and 2 zeros, that means even number of ones, and whenever you have the even number of ones, the output will be 0. Whenever you have the even number of ones, yes, correct. Now many of you coming up with the answer as 0, some of you telling 1, nah. So Ajit and Chinmoy, answer is not going to be 1, it's going to be 0. The correct answer is 0, option number A. Option number A. Okay, everybody, moving ahead to the next question. Lots of questions we have in the session to be discussed. The output of the circuit Y when all the logics are designed by TTL. What is the output of the circuit Y when all the logics are designed by TTL? Okay, when all the logics are designed by TTL. Now, what is the logic behind this TTL? Okay, because how you are going to use this? Have a look into this picture. The AND gate, you might be feeling that there is some data missing. There is no data missing. These are the floating inputs. There is no data missing. These are known as the floating inputs. And if you have the floating inputs, okay, in the TTL logic, in the TTL logic, the floating inputs will be equal to 1 in the TTL logic. That's what is the basic knowledge you need to have from the TTL logic here. Okay, so because the two inputs are floating, they will be taken as 1, 1 according to the TTL logic. So the output of this gate is 1. Whatever may be the output of XOR gate, I don't care, because what I get here is 1 plus X, and in the Boolean 1 plus X is equal to 1. So what is the output Y? It is just the inverter. So what is the complement of 1? That is equal to the 0. That is equal to 0. That's it. Correct. This is absolutely correct. Chalo, cool hai. Moving ahead to the next. Okay. So the correct answer here is also 0 as given by some of you. Correct. Yes, correct. तो floating input को यहाँ पे use करना था as 1 because the TTL logic is given. Next question, guys. Next question. What is the minimum propagation delay of the circuit given below? Okay, what is the minimum propagation delay of the circuit given below? Not the maximum, the minimum. Not the maximum, the minimum. So minimum कैसे निकालेंगे? So it's a very simple logic actually. Okay, if they want to talk about the maximum. Okay, if they want to talk about the maximum. If they want to discuss about the maximum, so what should be the answer according to the maximum, guys? Yes, yes, Akitej, we'll consider that. We'll look into that and plan. Maximum, tell me. So maximum means the delay. यहाँ पे given है and or both are having the 2 nanosecond of delay. This will have the 2 nanosecond delay, 2 nanosecond delay, 2 nanosecond delay, 2 nanosecond delay, right? And maximum delay means the first gate output has to be produced, then only the second gate will respond. Whatever the C input is ready, but you have to wait here. So 2 nanoseconds here. यहाँ पे आ गया 2 plus 2 4. Then you will count the delay of the OR gate. So 6 nanoseconds, and for the final output to be produced, the delay will be 8. Right, so maximum delay of the circuit will be 8 nanoseconds. So they commonly ask the maximum delay or the worst case delay, but here they are asking what? Here they are asking the minimum propagation delay. So now what will be the minimum case? Minimum delay means इसके पीछे का लॉजिक सिर्फ इतना है कि if suppose D is 0, right? If suppose the D is 0, then the output is 0. Correct. Why? Because if I take D 0, the output of the AND gate, suppose that is Y, that is also equal to 0, because if any one input is 0, you don't need to wait. You don't need to wait for the other input. Okay. So the output will become 0. Output will become 0. Okay. Just after the delay, the time taken by the last AND gate, and that is 2 nanoseconds. So if D equal to 0, Y is equal to 0 just after 2 nanoseconds, and that is what compromises the minimum delay. That is what compromises the minimum delay. Maximum पूछा जाता, then the answer would be 8. Right. Yes, Surajit. Okay, correct. So the correct answer here is the 2 nanoseconds. The correct answer for the question here is 2 nanoseconds. Okay, everybody? Yes. All cool. Chalo. Next one. Okay. Moving ahead to the next. Yeah, just related with the logic gate, some basic Boolean question also we can discuss now. Basic Boolean question also we can discuss. In the logic equation, A plus something is given to you. If C is equal to A bar, then which of the options are correct? Some basic Boolean logic questions also we can discuss. Okay. So if C is equal to A bar, देखो ना, if C is equal to A bar, so then equation is actually going to become, A plus B bar into C bar. What will be C bar? C bar will be A. तो ये हो गया A plus C, and C is equal to A bar. Let me rewrite this in terms of the new variable, plus B bar. C की जगह again आ जाएगा A bar, then you have A bar, then you have BC, and C is equal to A bar. Okay, multiplied by A plus B bar into C. C is equal to the A bar plus A C bar, and C bar is A. This is equal to 1, and we need to select the correct option actually. Okay, we need to select the correct option. So see guys, it's going to relatively become simple. यहाँ पे देखना, this is equal to A plus A B bar is A, and A plus देखो ये हुआ. Let me solve it in steps first of all. How much is this one, guys? Isko dhyan dena. A plus AB bar is A. Okay, then you are left with A plus A bar. A plus A bar will be equal to 1. Okay, now if you come here, A bar plus A bar is single A bar, and A bar, okay, then plus A bar B. A bar plus A bar B will be A bar. A bar common, 1 plus B is 1. So यहाँ पे बचा only A bar. Then what is left here is A plus A is A. इन दोनों को combine किया तो A, and then you have A plus A bar B bar. Okay, that is equal to A plus B bar. Basic Boolean theorems we can apply. The basic Boolean theorems we can apply. Okay, so ultimately your answer is this part is equal to A multiplied by 1 plus the B bar into A bar multiplied by A plus B bar equal to 1. Okay, so that tells me A, this is only A. Now देखो, when you open up the bracket and multiply, A bar into A is 0, so you only need to consider A bar B bar into B bar. B bar will be just B bar. So A plus A bar B bar. A plus, correct, A bar B bar is equal to 1. What is A plus A bar B bar once again? It is A plus B bar. So answer should be A plus B bar equal to 1. Any answer? Option number C. A plus B bar equal to 1. Option number C. Option number C. Just check it up. Correct. Shubhajit, Chinmoy, Surajit, correct. Yeah, Nikhila Pantham now correct. Right? You just made it correct. Correct? Yes. Okay. Chalo. Moving ahead to the next one. Okay. Y is equal to A XOR B XOR AB. Okay. Okay, then what is the simplified expression is? Okay, let me write down the question complete. Then simplified expression for Y is equal to, what is the simplified expression for Y? Okay, A XOR B XOR AB. So see, if you are going to use the XOR formula in chain, this can become little lengthy. Okay, and you are solving the questions which are of the level of BARC and HAL. Of the level of BARC and HAL, and as we have already discussed in the pattern, you have nearly less time, that is around 1 minute. Okay, approximately. So approach and questions have to be, little simple and realistic. Formula से जाएंगे थोड़ा सा unrealistic हो जाएगा. So if Y is A XOR B XOR AB, then what is the simplified expression? Then what should be the simplified expression? Check कर लेते हैं. Okay, so what you can do for this question is, just make a truth table. Okay, AB itself is a function of A and B, and then write down Y. And then write down Y. So AB are the two variables, so 0 0 0 1 1 0 and 1 1. Right? What is the AB? Okay, AB, so 0 0 0 0 into 1 1 into 0 1 into 1. Okay, now Y is 3 input XOR, and 3 input XOR mein, whenever you have the odd number of ones, output will be high. This is even number of ones, so output will be low. Right? Now what is Y as a function of AB? Right? What is Y as a function of AB? अगर आप इन दोनों से relate करोगे, so what should be the answer? The output is high if any of the input AB is high. Okay, so looking into this, I can say Y represents OR gate. Y is basically now representing just as a OR gate. That means Y is equal to A plus B. Logical OR, option number C. Logical OR, option number C should be correct. Yes? Yeah. That's what I see in the comment box also. Option number C can be definitely correct. Okay. Chalo, cool. Moving ahead to the next question then. The Boolean function, of course, K-maps are an integral part of minimization, as well as you can relate it with the combinational circuits as well. Yeah, option C is the correct answer for the previous question. No doubt regarding to that. Okay, so the Boolean function f is equal to summation of minterms 0, 6, 8, 13, 14 with the don't care combinations can be simplified to. Okay, so let's, because don't care involve 4 variable function, so let's take it as a K-map problem and try to solve this up quickly. Okay, let's try to solve this up quickly. Then we will go to the proper important combinational circuits question also. Okay, let's take 4 variables are named as A, B, C, D. Okay, so then this is 0, 0, 0, 1, 1, 1, 1, 0 according to the gray code 0, 0, 0, 1, 1, 1 and 1, 0. So this turns out to be A. This we call it as B because here B is high. We call this portion as C, and let's take here D as high. Now what are the minterms available? What are all the minterms? Okay, so you have 0, right? You have 0, then you have 4, 5, 6 is here, then you have 8, 13, 14. Okay, and then there are 3 don't care conditions also, that is 2 यहाँ पे आ जाएगा, that is a don't care condition. Then you have 4 and then 8, 9, this is the 10. Okay, this is the 10. Okay, yes. Okay, so Rajit says answer B. Everybody, you can also keep solving. Now we need to form the combinations. Okay, what are the combinations that you can form here? Definitely this is a quad, right? This is a quad, so you can, if you don't take this one, if you don't take the don't cares, you will be able to represent pair. Don't care can be 1 or 0 based on your requirement. You need to form the largest possible group. So definitely this is a quad, right? If you don't take the don't cares, it will just be a pair. Similarly, coming here, if you consider this one, okay, there are 2 possibilities to consider this one, I think. Either you can take corners. What about this one? Agar iski baat kare, this is alone. Okay, this is alone, and this is minterm number. This is just the 13 minterm. This is just the minterm number 13, and minterm number 13 should be 1, 1, 0, 1, A, B, C bar, D. Acha, if you just look into this, na, A, B, C bar, D, then only one option can be matched. There is only one option containing, okay, A, B, C bar, D. So your question sometimes can finish just like this. Maybe you don't need to solve completely. Your question can finish just like this. Okay, that is the option number B. That is the option number B. Okay, now other than that, this is definitely one quad, and this quad will be equal to how much? This is C and D bar. Okay, C and D bar is also there. Now as I'm telling you, for this one there are 2 possibilities, but the option may have B bar, D bar, so they are just going to treat it like this, all corner ones. Yeah, that's the best way, correct. So all corner ones taken, and that is B bar, D bar, option number B, perfectly matched. Okay, but as I told you, sometimes only one minterm was sufficient to match the options. Okay, but yeah, you should know the complete approach also. Sometimes you are able to solve by option, sometimes we may need to apply a few more seconds to solve it up completely. Moving ahead to the next one. The minimized form of the Boolean expression f a b c is product of the max terms. Product, see, yahan pe it should be written clearly. This is product. Product means product of the max terms should be given, not the min terms. Product of min terms will actually become 0, na? Correct? Yes. Previously B only be magna. Correct. Huh? B is the correct answer. All correct. Yes, guys, in the comment box. Coming to this one, product of the max terms. But if you look into the options now, okay, this is a product term, product terms, and then they are added. Okay, so the options are in the form of simplified SOP form, sum of products. Okay, because the options are in the form of sum of products, this becomes product of max terms ko maine min terms mein convert kar diya because I want the SOP answer, right? So then this should be 1, then 4, 5, 6, 7. 1 and 4, 5, 6, 7. That should be the answer. 1 and 4, 5, 6, 7. 1 and 4, 5, 6, 7. One and 4, 5, 6, 7. ठीक है. Sure. Now let's complete this problem. This is A, this is B, C, this should be A, this will become the B and C. Okay, and then you have the entries as 1, then you have directly 4, 5, 6, 7, all of them coming up. 4, 5, 6, 7. So definitely there is a quad coming up, and that belongs to, that is totally A, and there is a pair which is B bar C. B bar C, however you read the K maps, so that's up to you. So answer should be A plus B bar C. That is the Boolean function f, A plus B bar C, option number A. Option number, that's what I have in the comment box. Yes, exactly, that is what we have in the comment box also. Correct. A plus B bar C, all okay. Chalo. Moving ahead to the next one. Following is the K map of a Boolean function of 5 variables P, Q, R, S and X. 5 variable K map, but not a difficult one, don't worry. Okay, the minimum SOP expression for the function is, what is the minimum SOP expression for the function? 5 variable K map is given. Let's have a zoomed version of this. You need to find the minimum SOP form. The minimum SOP form. Have a look at the zoomed version. Okay, so as you know, 5 variable K map, we break it into 2 4 variable map and take the mirror image. Take the mirror image. So Rakesh, 2 lectures for network has been completed. This is the first. For around every subject we are taking up 2 to 3 sessions. Just have a revision question practice session. Okay, with the question practice, automatically the revision and the concepts get revised. And digital is a subject which is more and more question based. For some other subjects we'll also try to revise up the formulas, but digital is more question oriented, problem oriented, application oriented. Okay, so we take it into 2 mirror image K maps of 4 variable. In first variable we take the x0, okay, whatever maybe the MSB or whatever variable you want to take as the MSB, and here we take the x equal to 1. Now the ones are given to you. It's a very simple case that you need to do the grouping as you always do. Okay, now here it is RS, here it is RS, so this should be the R and this is the S portion. And here it is PQ, so this becomes P and this becomes Q. So what is the answer for this K map? This quad belongs to S as well as outside Q. So S and Q bar. S and Q bar. And this is the answer if X is equal to 0. Okay, if X is equal to 0, the function is suppose F. Okay, if X is equal to 0, the output is S and Q bar, right? 9. And if X is equal to 1, if X is equal to 1, what is the possible grouping here? This is what is the, again, a group of 4, a quad is being formed here, and that quad, let's again write down same RSPQ. Now this is RSP and Q. Okay, so this quad definitely belongs to Q and outside S, so S bar Q. So what is the function F? Okay, this is the answer if X is equal to 0. For X is equal to 0, you will use X bar. So X bar S Q bar. Okay, yeah, agar sequence mein likhe, how is the options written? P Q R S. Okay, so let's write it in the form of sequence. Q bar S, X bar, and this should be Q S bar X. If X is equal to 1, we use the true value of X. So Q bar S X bar, Q bar S X bar plus Q S bar X plus Q S bar X. Option number B. Option number B. Yeah, some of you are giving the option number B only as correct. So you know, 5 variable K maps are also simple to deal with, not like time taking. The simple one only. Right, next one only. Yeah, this is a now question expected from the decoders. How many 3 to 8 line decoders with an enable input are needed to construct a 6 to 64 line decoder without using any other logic gates? Answer for this, guys, without using any other logic gates. The simple trick to solve this question is, okay, see how many output lines you require. You require 64 output lines, and how many, the decoder that is given has 8 output lines. The decoder that is given is having 8 output lines. Okay, what you do is divide 64 by 8 and take the integral part, GIF part or floor function for this. 64 by 8 is 8 and the floor, the integral part of 8 is equal to 8. Just have to take the floor value, integral value, jo integer uske just niche hai. Okay, then take the answer and again divide by 8. 8 divided by 8 is 1, and what is the integral value of 1 is 1. Now take the 1 divided by 8, keep on dividing by 8 unless and until you get 0. So 1 divided by 8 is actually 0.125. 1 upon 8 is 0.125, and if you take the floor value, the integral part of 0.125 is the 0. Greatest integer function. Greatest integer function. So that is equal to 0, and as soon as you get 0, you have to stop. Okay, you have to stop, because again if you keep dividing 0 by 8 you are going to get zeros only, so you have to stop here. So what should be the answer? The answer is obtained by adding all these results. Okay, the answer is 8 plus 1 plus 0, and the answer should be 9. Option number C. Option number C. Yes, Rakhi, it will be considered correct only. Okay, the correct answer is 9. So Rajit, it's not 8, it's going to be 9. Okay. Hope you have got this logic. Moving ahead. Okay, so just do this division method. Okay, and follow the GIF, the greatest integer function, or the floor value. The floor value. Okay. Any confusion in this method, you can let me know. If you have any confusion in this method, you can please let me know. Okay. Okay, so if I want, I can generalize this. Suppose you have an n cross m decoder to be built using, suppose, x cross y decoder. Okay, so what you have to do? Okay, first you have to divide number of output lines required by the number of output lines of the given decoder, m by y. Divide m by y. Okay, suppose the answer is equal to a. Let me write any numbers. Then you have to divide a by y. Okay, again you have to divide a by y. Division same sahi hoga. Okay, so suppose the answer is b. Then you have to divide b by y, and suppose the answer is equal to c. Keep doing. Okay, when you get 0. When you get 0. Okay, until you get 0. So answer is, the number of decoders required is a plus b plus c up to the 0. Okay, this is the method. This is the generalization, I can say. This is the trick of solving this question, I can say. Ekdam simple sa trick hai to get the total number of decoders. Okay. Consider an 8-bit ripple carry adder for computing the sum of a and b, where a and b are integers represented in 2's complement form. A and b are integers represented in 2's complement form. Sir, they are represented in 2's complement form. Okay, if the decimal value of a is 1, this question is talking about ripple carry adder, but this is a very logical question. Okay, ripple carry adder ka use yahan pe nahi hoga. If the decimal value of a is 1, what is the decimal value of b that leads to the longest latency for the sum to stabilize? Longest latency for the sum to stabilized. What is the meaning of longest latency here? Means the largest delay, जिसमें सबसे ज़्यादा time लगेगा, the largest delay chain. Okay, so what should be the decimal value of b? Okay, for the sum to stabilize, and largest delay will occur. What is that you know about carry ripple adder? The largest delay will occur. Okay, if carry propagates to all stages. If carry propagates to all stages, that means if a, which is given to you as 1 means of course plus 1, and this is a 8-bit case. Ye dhyan rakhna, this is a 8-bit case. So how do you write down plus 1 in 8-bit? It's just 1 and 7 0 0 0 0 0 0 0 0 1. What should be the value of b? That is what the question is asking. Okay, now there should be a carry. Okay, propagating through every state. Okay, so how will you get the carry here? 1 plus 0 is 1. That will not give you carry, na? That will not give you carry. So it has to be 1 plus 1. That will give you 0, and the carry is 1. So carry is generated. Now again, if you write here 0, 1 plus 0 plus 0, there will not be any carry. So write down, keep on writing here 1 again. 1 plus 1 0, carry 1. Now again 1, you want one more 1. 1 plus 1 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. 1 plus 1 again 0, carry 1. 1 plus 1 0, carry 1. 1 plus 1 0, carry 1. That is the final carry. Okay, so carry propagates through every state if the value of b is, what is the decimal value of b? A and B are represented in 2's complement form, guys. What is the decimal value of B? Tell me. Now some of you might think, sir, when you convert this into decimal, this is 255. This is 255. Now this is a 2's complement number. This is a 2's complement number. 1 1 1 1 1 1 1 1, and if you want to see the MSB is 1, indicating negative number. MSB equal to 1 represents a negative number. So this is a negative number. And how negative numbers are stored in 2's complement machine? By taking the 2's complement. So how to get the original number? Again take the 2's complement. Complement and complement cancel each other. तभी तो complement new use करते हैं. So what is the 2's complement for this? What is the 2's complement for this? 2's complement. So first you take invert all the bits. This is known as the 1's complement. Then you add 1. So you get this one. Okay, and how much is this? This is equal to 1. Okay, but it is a negative number. So combining the sign, the magnitude representation is 1 and the sign is negative. So B is equal to -1. The correct answer is option number B. The correct answer is the option number B. Okay, right. The correct answer is option number B. Correct. Chalo. Moving ahead to the next question. A 16-bit ripple carry adder is realized using 16 identical full adders as shown in the figure. The carry propagation delay is given to you TC 12 nanoseconds, and the sum propagation delay TS is given to you as 15 nanosecond for each full adder. What is the worst case delay of this 16-bit adder? Guys, what is the formula? What is the formula for propagation delay of the ripple adder? Okay, it is given by n-1. For the final sum bit to generate, you have to wait for n-1 carry, and then you have to wait for the output of the last full adder, and the output of the last full adder will come, okay, maybe after TS or TC seconds. We have to wait for the worst case delay, maximum delay. This is the formula that you should be applying. This is the formula for n bit. So what is the answer that is going to come here? It is equal to 16 bit, another 15 into 12 plus the max of 12 or 15, which seems to be 15. So correct answer is 195 nanoseconds. 195 nanoseconds. Let me see the comment box also. 195 nanoseconds. Yes, some of you given correct up to this time. 195 nanoseconds is the final answer. Okay, 195. A very simple question. As per BARC and HAL level only, we'll confine the questions. Next one. A 1-bit full adder takes 75 nanoseconds to produce the sum and 50 nanoseconds to produce the carry. क्या बोला है? A 1-bit full adder will take 75 nanoseconds to produce the sum and 50 nanoseconds to produce the carry. A 4-bit parallel adder is designed using this type of full adder. What is the maximum rate of additions per second? Okay, that can be provided by 4-bit parallel adder is A into 10 power 6 addition per second. What is the value of A? Okay, पहले एक single bit adder means a full adder, single bit full adder they are talking. What is the given here? TS is 75 nanosecond and carry के लिए चाहिए 50 nanoseconds. A 4-bit parallel adder is designed using this type of full adder. What is the maximum rate of additions per second that can be provided by 4-bit parallel adder is A into, ठीक है, तो पहले हम TPD निकालेंगे, right? What is the TPD? What is the maximum or worst case propagation delay? Here it is how much? 4-bit na? Okay, 4-bit मतलब n-1 is 3 times carry 50 plus max of 50 or 75. So this becomes 225 nanosecond. Okay, this is the delay. This is the time required for one addition, delay. Okay. Now question is asking you what is the rate of additions per second. तो इसको ऐसा समझते हैं. Okay, per second ना. So 225 nanoseconds. Okay, I am able to do one addition. So in 1 second, how many additions? So it should be 1 is divided by 225 into nanosecond 10 power minus 9 additions. Okay, so this becomes 10 की power 3 upon 225 into 10 की power 6 additions. अच्छा sir, calculator is not allowed ना? ठीक है, बार्क में तो एटलीस्ट यस यू हैव द वर्चुअल कैलकुलेटर, ओके, तो अगर बार्क के हिसाब से तो ओके है, बट स्टिल यू डोंट नीड कैलकुलेटर. 1000/225 अप्रोक्सीमेटली कैंसिल्ड एज 4 ना, 44 तो नहीं होगा. 1000/225 अप्रोक्सीमेटली कैंसिल्ड एज 4, सो यू कैन जस्ट टेक इट एज 4. या यू कैन जस्ट लुक इनटू द ऑप्शंस एंड सी 4.44 ना, एग्जैक्ट 4 तो नहीं होगा कहीं से कहीं तक. 4.44 10 power 6 additions per second. So what should be the value of a? 4.44. 4.44. Correct answer. Yes. Some of you giving the B. That is the correct answer. That is the correct answer. No doubt, guys. That is a very correct answer. Yes, guys. A simple question from multiplexer here. The multiplexer. The gate. A gate having two inputs, A, B, and one output Y, is implemented using a 4x1 multiplexer as shown in the figure below. A1, MSB and A0 are the control bits, and I0 to I3 are the inputs to the multiplexer. Inputs to the multiplexer. What are the gate? Okay, the gate having two inputs, okay, and one output is implemented using multiplexer. What is that gate? A1 is the MSB, okay, and A0 is the, of course, LSB are the control bits. अब देखो simple सा logic है यहाँ पे. Let's do it up very quickly. Okay, when the select lines, what is there on the select lines? A and B. Let's write it here. Okay, when the select lines are 0, 0, so A bar, B bar. Okay, then you give I0, and what is coming to the I0 is A, right? Plus select line 0, 1. 0, 1 means A bar, B, and then you select I1. Let me keep writing here. A, I1 pe you have B, I2 you again have A, and I3 pe you have B. A, B, A, B. So next is B, right? 1, 0, select line 1, 0, so A, B bar, then you again get A, and select line 1, 1, A, B, then you get the I3, which is again equal to B. Okay, A bar into A 0, A bar into B into B, B into B is 1, so A bar B, A into A is 1, so A B bar, A B B, that is just A B. So what it should be simplified as? Okay, you are getting the 0, 1, 1, 0 and 1, 1 combination. Okay, then the answer is very clear. Okay, अब देखो, if you want to solve by the Boolean also, there is no issue. You can take up the Boolean case also. Boolean में last को simplify करोगे तो you get what? A bar B plus यहाँ से आपने A को common लिया, B plus B bar is 1, so you get A, right? A plus A bar B is A plus B. Okay, पहले इन दोनों को हमने simplify कर लिया. A plus A bar B is A plus B. Otherwise, I am trying to give you the hint earlier also. A bar B, A B bar, A B. 0, 1, 1, 0, 1, 1 पे output high है. That is a OR gate basically if any one of the input is high. Okay, so the correct answer is D. Correct answer is D. Some of you are giving C also, right? सुराजीत सर पैरेलल एडर, हाँ सुराजीत, पैरेलल एडर में सारे बिट्स तो साइमल्टेनियसली अप्लाई होंगे, बट पैरेलल एडर सी, okay, you apply, suppose I take a 2-stage case only, you apply both the inputs, okay, but this has a carry output na, okay, that goes to the carry input. So unless and until this gets the carry output ready, how the second adder can start? Similarly, okay, when this gets the carry output, then only the third adder will start. Isn't it, Surajit? So basically that is what makes the ripple adder slow, na? It's simple design, but it's little slow because every adder has to wait for the previous carry. Okay, so last full adder will have to wait for how many carries? Okay, how many carry delay will be counted? n-1 times, excluding that last one. That is why we write n-1 TC, na? That is what I wrote here. n-1 times carry delay plus the last full adder, whatever is the maximum for worst case, TC or TS. Surajit, okay? Chalo, next case, yeah, this one is done. Next case, guys. The combinational logic circuit shown in the given figure has an output Q, which is how much? Has an output Q, which is equal to the how much? What is the output Q here? Right. So once again, guys, a simple case. Likh lete 0, 0, A bar, B bar. You get the I0, which is C. Right. Then 0, 1 pe 1, 1, 0, 1, 1, 1, 1. Okay, just get it simplified. It will be simplified very simply actually. So from here, I can take A bar common. So B plus B bar C A bar common liya, so B plus B bar C will be B plus C. One stage is simplified here only. From the last two stages, A is the answer. B plus B bar is 1. A common, B plus B bar is 1. Okay. Now, A plus A bar into X will be A plus X. So you might have observed I am using this very commonly, and this is actually very common. X plus X bar Y, absorption is X plus Y. Okay, this complement will be omitted. X plus X bar Y is X plus Y. Na? So similarly, A plus A bar into suppose X. Okay, is A plus X directly. So A plus B plus C, that is the answer. Okay, A plus B plus C. Okay, the correct answer should be option number B. Correct answer is option number B. Okay, yes, okay, for this one nobody in the comment box yet, so people are still trying. I think correct answer is B, option number B. Okay, seems good. Moving ahead to the next question. For the multiplexer shown in the figure, what is the Boolean expression for the output Y? What is the Boolean expression for the output Y? Okay, it's a 8x1 mux, but still following the same methodology. Okay, very simple Boolean question. See, जो ones है ना केवल उसको consider करेंगे. So I1 means 0 0 1. A bar B bar C. Next I4 1 0 0. A B bar C bar. Next I5 1 0 1. A B bar C. And next I7 is there. That is 1 1 1 ABC. No need to write down the select lines which have the inputs connected with the 0 variable, because anyways that's going to be converted to 0. Okay, so now you can just simplify this and get the answer. Just simplify this and get the answer. Okay, so from the first two you can see what is the common variable. You can take B bar common, A bar C plus A C bar. नहीं, इसको simplify नहीं करेंगे. Okay, or you can feed it in the K-map also, whatever you feel like. This is A B bar, this is simplified A B bar, C bar plus C is 1, right? And C commonly, okay, so this is A B C and this is A bar B bar C. Okay, now this is further equal to A agar common liya, so this is A bar B bar C plus, if I take A common, then B bar plus B C will become B bar plus C. Okay. And then from here B bar is common, A bar B bar C plus A B bar plus AC, and B bar is common. If you take B bar common, A plus, if you take the B bar common, A plus A bar C will be A plus C plus AC, right? So A B bar, correct, A B bar plus AC, A B bar is coming plus AC is coming, and then plus B bar C is coming. Option number C. Option number C. Or you can use the K-map also directly. Option number C. Check करना है नहीं, A नहीं. Option number C is coming up finally. Let me check again. B bar, A plus A bar C is A plus C. Correct. Option number C. Okay. Yes, yes. So some of you saying C, some of you opting for A also. So you can recheck. C is the final correct answer, guys. No doubt. C is the final correct answer here. Moving ahead to the next question. Find the output Y. It's just the cascaded multiplexer. That's also simple case. That's also the simple case. And if you're getting the answer, if you're able to match the answers, do hit the like button. Okay, and also do subscribe the session, subscribe the channel, I mean, because all of these sessions of BARC, HAL, and then some preparation strategy sessions, GATE 23 sessions, all of them coming up on the same channel. Okay, so you get automatic notifications. Find the output Y. Find the output Y. So see, जो zeros है उनको तो discard ही कर देंगे. Only consider 1 and this part is equal to the A. Okay, and let's say this output not named. So let's say this is X. So what is the X? What is the X is equal to 0, 1. A bar B multiplied by 1 and then final 1, 1. 1, 1 pe you have A. So this is equal to simply A bar B. A into A is A. So AB. Okay, out of which answer is B. A bar plus A is 1. So X is equal to B. Now what should be the Y is equal to? Now Y is the output of 2 cross 1 mux. If the select line which is C is 0, you get I naught, that is X. If the select line C which is equal to 1, you get the I1 which is directly coming up here from B. Okay, now put down the value of X. So the y is equal to c bar into x. X is b plus cb. Acha, out of this b is common and c bar plus c is 1. So the answer is b. Do I have that? Correct. Yes, yes, yes. Y is equal to b. D is the correct answer. See, this was simple one. Simple one. Y is equal to the b. Okay. Chalo. The logic function implemented. That is again simple one. You just have to apply basic Boolean or K-map knowledge here. Nothing much. Okay. So isko bhi quickly ek baar solve kar lete hain. Okay. What is the logic function implemented by the 4x1 mux? The MSB is x. The LSB is y. Select line 0, 0. That is x bar, y bar. Then the input is x. Select line 0, 1. X bar, y. And the input is y. Select line 1, 0, x, y bar, and the input is x. Select line 1, 1, and the input is 0. Okay, 1, 1 means x, y. So first term is also 0. Okay, second term is x bar, y into y is just 1. Third term, x into x is 1, so x, y bar, and last is anyway 0. So you have x, y bar, x bar, y plus x, y bar, that is nothing but x XOR y. So this is representing x XOR option number C. Yes, guys, correct. Option number C. D nahi. C. XOR nahi, XOR hai, clearly. Some of you are telling XOR also. No. Option B. Sorry, option C, XOR. Correct? 100%. Okay. Correct answer is XOR, option number C. All cool. Okay, the Boolean function product of max term 0 to 47 is to be implementing using the multiplexer. Okay, shown in the figure. Which of the following there is some typo error, I think. Choices of inputs to multiplexer will realize the Boolean function. Which of the following choices will realize the Boolean function? Tell me. Okay, now what is there on the select line? ये आपको देखना पड़ेगा. Select line S1, S0. Okay, whether it is CB or BC. Okay, that also you have to check. Okay. Let's first try in the sequence BC. Sequence में चलते हैं. So let's try with BC. Okay, if it doesn't work out, then I can try something else. Either BC. As per the options, either BC or CB. Okay, A is on the select line. On the input line. So what should be there on the I0, I1, I2 and I3? Okay. So iska implementation table banayenge. What is the trick to solve this? So the select lines, I am choosing it as BC. So what goes on the data line, what goes on the input line is A. The only variable that will go there is A. So what is the implementation table for this? Okay. So you will have the two rows of the implementation table. One is for A bar. One is for A, right? And then here I write down the input lines I0, I1, I2, I3 to be decided. Acha. Now, what are the minterms to be written in this implementation table, guys? Now, A bar, okay, if you write down ABC, the function is ABC, A being the first one, MSB, okay. When you write down ABC, it starts with 0, 0, 0, 0, 0, 1, 0, 1, 0. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. यहाँ तक देखोगे ना, A is low. This corresponds to A bar. Then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are the cases where A is high, and where the A is high, this corresponds to A. So what are the minterms that will come in the row corresponding to A? Is the minterm from 4, 5, 6, 7. And the minterms corresponding to A bar, where the A is low, is 0, 1, 2 and 3. Acha. Now you have to see what are the minterms given in the function. Okay, so we need to convert this into the minterm form, and F will become the summation of the minterms, those integers which is not in the max term list. So 1, 0, 2 ko hata de, then 3 and then 5 and then 6. 1, 3, 5 and 6. Okay, so this is 1 and 3 and 5 and 6. Now you have to go column by column. I0. What is the minterm that is circled? Nothing. So 0. Here both the minterms are circled. Matlab A bar plus A, that is 1. This is minterm corresponding to the row of A, and this is the minterm corresponding to the row of A bar. So sequence should be 0, 1, A bar. 0, 1, AA bar, 0, 1 AA bar with the select line BC, option number D can be a perfect match. 0, 1 AA bar with the select lines BC. Right. The correct answer is option number D. Okay, the correct answer is option number D. Right. This is the implementation of a function to be implemented using the multiplexer, the 4x1 multiplexer. Again, a reminder, guys, that this coming Saturday, the 5th March, for all the GATE 23 or 24 aspirants, if you are planning to re-prepare or if your juniors are willing to prepare, okay, so what should be the strategy? What is the right time to start, and what are the tips and tricks from the BYJU'S experts? And this session is going to be taken by me along with your favorite Ashutosh Saxena sir this Saturday, 5th March, 8 p.m. Do not forget to attend this session, and do subscribe the channel if you want more of these sessions so that you get notified. Do keep on liking the session, and you can connect on 5th March at 8 p.m. Also guys, tomorrow, okay, this is coming up tomorrow at 10 p.m. Okay, if you are getting low GATE score, but still there are some branches which you are not aware of, some interdisciplinary courses, MS options that can still get you into old IITs or IISc even with the low GATE score. Sir, what are those branches? Okay, what are those branches? How to get into IISc or IIT, your dream college, even with the low GATE score, or whether you should go with in these branches or not. Okay, what is my opinion, that we are going to discuss tomorrow at 10 p.m. in this particular session on the same channel. Okay. Yes, Shivajit. Okay. And guys, one more thing tomorrow. Oh, what is this? Sorry. One more thing that we are planning for tomorrow is same time, 8 p.m. BARC class is again there. Okay. BARC class is there. That is again BARC and HAL. Of course, we are having the revisions, practice sessions, question for both. Again, digital electronics like today, and tomorrow we are going to take the question of sequential circuits and ADC DAC. Okay, sequential circuit, which is a very important topic for all competitive examinations. So that is same time tomorrow at 8 p.m. After that, you will have 2 sessions of analog. So I'm telling you, per subject around 2 sessions we are having. 2 sessions of network already done, 2 sessions of digital. Then you have 2 sessions of analog. That is on Friday and Saturday. That will be morning. That will be morning session, 11 a.m. Right. So keep on just following this BARC series and BARC schedule to have the complete revision. Okay guys, so with this, I Rakesh Talreja will sign off for this particular session. Okay, around 18-20 questions we nearly solved today. Tomorrow also bringing you lots of questions, especially the very important topics like sequential circuits, and also few questions on ADC and DAC part. Okay, see you tomorrow on the same channel at 8 p.m. and also at 10 p.m. Tomorrow we'll have 2 sessions from me, the same channel. Do not forget to subscribe in case you haven't subscribed. See you tomorrow at 8 p.m. First of all, bye bye, thank you, stay safe and take care of yourself. Right? Yes, and today's PDF, चलो PDF की बात भी कर लेते हैं. I will share in my Telegram channel. Today's PDF I will share in my Telegram channel. And as always, I will make it as a password, simple password. Randomly I am writing DG1, digital first session, DG1. Okay, if in case you are not into my Telegram channel, I'll share the link of the Telegram channel so that you can get the PDF. So this is the password. This DG1 is the password for the PDF. DG1. No spaces there, all small. DIGI, the number 1. Okay, DIGI number 1. Okay guys, bye bye, thank you, stay safe, take care, and see you again. There's a link of the Telegram I've again shared in the comment box.